In this video, we're going to learn how to solve inequalities with multiplication and division. Right now, I'd like you to stop the video, copy these two problems into your journal, and solve them as you would a normal two-step problem. And then, before you start the video, I want you to test answers, both answers that should work and answers that should not work in each one, just like we did in the first video, to make sure that your solutions are correct. And restart the video when you've finished solving the problems and doing the check. Okay, so we'll take a look at the first problem first, of course. And so let's see what we do. So the first step would be to add 1 to each side. We get 5x is greater than 25. We divide each side by 5, and we'll get x is greater than 5. Right? And this is what it looks like on a number line. So a number greater than 5 should make this true. A number less than 5 should make it false. And if we do those tests, we'll see in fact that it's true. A number greater than 5 makes this true. That's 30 minus 1. That's 29 is greater than 24. That's correct. The number 5 should not make this true. 5 times 5 is 25. Minus 1 is 24. Is 24 greater than 24? No, but that's okay because 5 should not work. And 4 also should not work. So we try 4. 5 times 4 is 20. Minus 1 is 19. 19 greater than 24? Nope. But that's okay. That's exactly what should happen. Now let's take a look at using the same method with the second problem. So we'll subtract 3 from each side, and we'll get negative 2x is less than 8. Then we will divide each side by negative 2. And if we do that, the left side just becomes x. The right side becomes negative 4. So the solution that we have is x is less than negative 4. That's what the graph looks like. And we're going to test numbers that should work and shouldn't work. Now negative 5 should be a solution to this, and we'll test that. So let's test it. Negative 5. So negative 5 should work. So negative 2 times negative 5 is positive 10, plus 3 is 13. 13 less than 11? That's not true. There must be some mistake. Well, the number negative 3 should come up false. So let's try that. Plug in negative 3. Negative 2 times negative 3 is 6, plus 3 is 9. But 9 is greater than 11. It should have failed. So something is wrong, and now we're going to have to figure out what is wrong. Now, in order to do that, we're going to start with two numbers, and we're going to find out what happens when we multiply them by something positive and when we multiply them by something negative. So let's start with the inequality here, 2 is less than 4. And the first thing that we're going to do is multiply each of those numbers by 2. 2 times 2 is 4, and 4 times 2 is 8. So the inequality now is 4 is less than 8. So when we multiply these numbers both by 2, the inequality is still true. Now we're going to multiply each of these numbers by 5, and let's see what happens. So when we multiply each of those by 5, well, 4 times 5 is 20, 8 times 5 is 40, and 20 is still less than 40, so that's fine. Now let's multiply by 1/4. We'll multiply by a fraction and see what happens. Okay? So 20 times 1/4 is 5. 40 times 1/4 is 10. So we see that 5 is less than 10, and everything's fine. Now, let's multiply both sides by negative 3. So if we multiply 5 by negative 3, we get negative 15. We multiply 10 by negative 3 and get negative 30. But wait, negative 15 is not less than negative 30. Negative 15 is greater than negative 30. So it looks like when we multiply by a negative number, we have to switch the sense of the inequality. Let's try it one more time just to be sure. So here, we'll multiply each of these numbers by negative 1/5. Negative 15 times negative 1/5 is 3. Negative 30 times negative 1/5 is 6. And there again, from the last step to this one, we need to switch the sense of the inequality, or as you might say, flip the inequality, to make sure that it stays true. Now let's go back to the problem that we got wrong before and see if we can make it right. Now, as before, the first step is going to be to subtract 3 from each side to get negative 2x is less than 8. And then we divide each side by negative 2, and because it's negative 2, we switch the sense of the inequality, or flip the inequality sign, and we get x is greater than negative 4. And now we have this solution as a graph. So let's check. Now, when we check negative 5 is not greater than negative 4, so negative 5 should fail, and negative 3 should make it true. So let's see. We test negative 5. Okay, negative 2 times negative 5 is 10, plus 3 is 13. 13 is not less than 11, but that's okay, because negative 5 should fail. Now, let's try negative 3. So negative 2 times negative 3 is 6, plus 3 is 9. 9 is less than 11, and that is true. So that is actually okay as well, because negative 3 should work. Right? So, and then if we test negative 4, just to be sure, negative 2 times negative 4, that's 8, plus 3 is 11. 11 less than 11? Nope, it's not less than 11, but that's okay. Now I'd like you to try these two examples. Please copy them into your journal, do all the work, stop the video before you do the work, and then check your work by restarting the video. Okay, and I'm going to quickly show you these solutions. For the first problem, we will multiply each side by negative 3 to clear this denominator here, and we flip the inequality, or switch the sense of the inequality. So our solution is x is greater than or equal to negative 42, and the graph should look like this. And we'll do a check, and we don't have to check numbers that are right next to the solution. 0 should make it true, and in fact it does. 0 is less than 14. Negative 42 should make it true. Negative 42 over negative 3 is 14. 14 is less than or equal to 14, so that's true. And negative 45 should make it false, because negative 45 is out here. Negative 45 over negative 3 is 15. 15 isn't less than 14, so that's okay. And now finally, let's check this solution. We subtract 7 from each side, divide each side by negative 4, and switch the sense of the inequality. Our solution is x is less than negative 6. That's what it looks like. And I'll leave it to you to check to see that that solution is correct.